sharing this video on the exclusive examples of the textbook on the properties as well as the reduction formulae. So it will be like a miscellaneous problems to you. So please avail this. Integral 1 to 4 x root x square minus 1 dx. So this is, if you see this, x square minus 1 derivative is 2x. Therefore here 2 is missing, for which we need to balance with a 2. So multiplying and dividing with 2 I will do. So 1 by 2 root 1 to 4 2x into square root of x square minus 1 dx. So now we have a formula that f dash x into root of f of x dx. We have a result. What is the result? We have integral root f of x into f dash x dx is 2 by 3 f of x whole power 3 by 2 plus c. So, because how do we get this? This is the form f of x whole power n into f dash x. F of x whole power n plus 1 by n plus 1. Here power n is whole power 1 by 2 root na. So that is what that is equals to 1 by 2. This is root f of x into f dash x dx. 2 by 3. What is f of x here? X square minus 1 whole power 3 by 2. Since the process is over, 1 to 4 is to be written here. 2 gets cancelled. 1 by 3 into x square. In the place of this, substitute the upper limit. So 4 square minus 1 whole power 3 by 2 minus 1 square minus 1 whole power 3 by 2. So 1 square minus 1, this is 0. 4 square. So 1 by 3, this is square and root will be cancelled. 4 cube, 64. So 64 by 3. You need not come right from the beginning of this problem. So x is equals to 2 sin theta, dx is equals to 2 cos theta, d theta and all. These many steps are not important, because we know that integral root of a square minus x square dx is x by 2 root of a square minus x square plus a square by 2 sin inverse x by a plus c. This we know. So applying the same here also. What is x here? 4 means this is 2 square minus x square. So a is equals to 2 here. X by 2 is same into square root of a square minus x square. So same we will be getting again, because if it is root a square minus x square, the same is continued here. In the same way, root 4 minus x square, same, plus a square by 2. What is a? 2. 2 square by 2 sin inverse x by a. X by a value is 2. Since the process is over, the limits are to be written here, 0 to 2. So now, wherever you find the upper limit, wherever you have the x, you just have to substitute the upper limit 2. So let us do that. 2 by 2 root of 4 minus 2 square plus 2 sin inverse x value is 2 by 2. So this is all upper limit minus lower limit is 0 by 2 into something. This is 0. 2 sin inverse 0 by 2 is sin inverse 0 by 2 is 0. Sin inverse 0 is 0. So lower limit as a whole will be 0. 2 gets cancelled. So here 2 square is 4. 4 minus 4, this is 0. So 2 sin inverse 1 value is pi by 2, because sin 90 is 1, sin inverse 1 is pi by 2. So 2 gets cancelled. We are left with pi. Integral 0 to 16 x power 1 by 4. So, if root of something is there, to avoid that root, we used to take x equals to t square. So that square and root will be eliminated. Here x power 1 by 4, that is fourth root. Let us take x equals to t power 4. Therefore, power 1 by 4 whole power 4 will be cancelled. So in this way we need to think. Okay, solution, let x equals to t power 4. So now x is a function of t. Therefore t is independent variable, x is dependent variable. Actually we need to do is d by dt of x is equals to d by dt of t power 4. So dx by dt is equals to 4t cube, or simply directly dx equals to 4t cube. So this we have discussed before. Therefore I am just avoiding and writing direct steps here. So upper limit. Since this is the function of x, therefore 0 and 16 are also the are the limits of x. But this x we are trying it to change in terms of t. Therefore we need to change the limits for t as well. So t power 4 equals to x value is 16. 16 is 2 power 4. Therefore t is equals to 2. Likewise lower limit is t power 4 is equals to x. Therefore t is equals to 0. Therefore the given function has become 0 to 16. So 0 to t. X power 1 by 4 is x is t power 4. Whole power 1 by 4. So 4 gets cancelled. So to cancel out this, we have taken in this way. Dx is 4t cube dt by 1 plus. If x equals to t power 4, what is x power 1 by 2? This is t power 4 whole power 1 by 2. So this is t square times. So this is t square. This is equals to 4 is to be taken out since it's a constant. 0 to 2. This is t into t cube. So t power 4 by 1 plus t square dt. So this is a fraction and the numerator's degree is 4 and denominator's degree is 2. Therefore what do we do? So we need to divide this t power 4 with that of 1 plus t square. Let us do that. So t square plus 1 t power 4. So t square into t square is t power 4. This is t power 4. T square into 1 t square. T square into 1 t square. So minus minus gets cancelled. This is minus t square. 2t square is minus t square. Minus into minus 1 into plus 1 is minus 1. So this is plus, this is plus, gets cancelled. We are left with a 1. Therefore, this can be written as 4, 0 to 2, t square minus 1, q plus r by divisor. So 1 by t square plus 1 whole dt. This is equals to 4, 0 to 2 t square dt. I am separating minus 0 to 2 1 dt plus 0 to 2 1 by t square plus 1 dt. So 4 integral t square dt is t cube by 3 from 0 to 2 minus integral 1 dt is t from 0 to 2 plus integral 1 by 1 plus t square dt is tan inverse t from 0 to 2. So 4 1 by 3 t cube is 2 cube minus t cube is 0 cube. Upper limit minus lower limit is over. Minus of 2 minus 0 plus tan inverse 2 minus tan inverse 0. Simply I'm substituting upper limit minus lower limit wherever you find t. So this is 4 into 2 cube is 8 into 1 by 3, 8 by 3. So minus 2 plus tan inverse 2. Tan inverse 0 is 0 anyway. So 4 into 8 minus 3 2s are 6 plus 3 tan inverse 2 by 3. So the final answer is 4 by 3 into 2 plus 3 tan inverse 2 equals to 4. 2 by 3 plus 3 by 3 is 1 into tan inverse 2. The next question, minus pi by 2 to integral minus pi by 2 to pi by 2 sin mod x dx. So we have done enough problems as far as the modulus problems are concerned. So as far as modulus is concerned, the property is it will be positive in some interval and negative in some other interval. So where it is being cut will be sorted out. How? See, between minus pi by 2 and pi by 2, we need to have a limit where it varies from positive to negative or negative to positive. Okay, solution. So sin modulus of x is equals to sin minus x if x less than 0 and sin positive x if x greater than or equals to 0. So that is equals to minus pi by 2 to pi by 2. Therefore, it will be broken at x equals to 0 between minus pi by 2 and pi by 2. So sin modulus of x dx is equals to minus pi by 2 to pi by 2, minus pi by 2 to 0, sin modulus of x dx plus 0 to pi by 2, because a to b f of x dx. So c is lying in between a and b. We have a property that a to c plus c to b. So that c is 0 in between minus pi by 2 and pi by 2. So this is sin modulus of x dx. So minus pi by 2 to 0. So which is less than 0. This will be sin mod x is sin minus x dx plus 0 to pi by 2 sin this is 0 to pi by 2. More than 0 it is positive. So sin x dx. We all know sin minus theta, since it is an odd function, sin minus x is minus sin x. So minus pi by 2 to 0 sin x. Sin minus x is minus sin x dx plus 0 to pi by 2 sin x dx. What is integral sin x? Minus cos x. Minus of minus plus cos x from minus pi by 2 to 0. Integral sin x is minus cos x. So minus cos x from 0 to pi by 2. Now simply apply the limits. Cos 0 is 1 minus cos 90 is 0. Cos 0 is 1 minus cos minus pi by 2. Cos minus pi by 2 is plus cos pi by 2. Cos pi by 2 is 0 minus cos 90 is 0 minus cos 0 is 1. So minus of minus is plus 1. 1 plus 1 is 2. So the next question is integral 0 to pi by 2 sin power nx dx is to be shown as 0 to pi by 2 cos power nx dx. The concept is crystal clear. So we have integral 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. So that is equals to 0 to pi by 2 sin power nx dx. What this property says is 0 to a, same 0 to a we are getting. So wherever you have x, A minus x means upper limit minus x is what we are getting. So, in this way, if we proceed 0 to pi by 2, sine power n, in the place of x, upper limit minus x, so pi by 2 minus x dx. So, this is equals to 0 to pi by 2. Sine 90 minus x is cos x whole power n, so cos power nx. Simply we can show this. So, the next problem is integral 0 to pi by 2 cos power 5 by 2x by cos sine power 5 by 2x plus cos power 5 by 2x dx. This is simple application of the above one. Solution we have, let I'll take, so we have integral 0 to a f of x dx is equals to 0 to a f of a minus x dx. So this is equals to 0 to pi by 2 cos power 5 by 2 pi by 2 minus x by sine power 5 by 2 pi by 2 minus x plus cos power 5 by 2 pi by 2 minus x dx. So this is equals to 0 to pi by 2 cos 90 minus x is sin x whole power 5 by 2. So sin power 5 by 2x by this is cos power 5 by 2x plus this is sin power 5 by 2x. So dx given is 1 and this is 2. So let us do addition of these two, 1 plus 2, I plus I, this is also I. So I plus I is 2I is equals to 0 to pi by 2. So 0 to pi by 2 is common. So if we take the LCM, sin power 5 by 2x plus cos power 5 by 2x is what we are getting. So if I am adding numerator cos power 5 by 2x plus denominator sin power 5 by 2x dx. So this cancelled out. Integral 1 dx is x from 0 to pi by 2. Since the process is over, 0 to pi by 2 is to be written here. So pi by 2 minus 0 is equals to 2i. Therefore, I is equals to pi by 2 by 2, which is pi by 4. He is asking us to prove integral 0 to pi by 2 x by sin x plus cos x dx is pi by 2 root 2 log root 2 plus 1. So this kind of problem we had in the exercise 7b as well, third Roman. So let us do this. As usual, let us take it as I. Let I is equals to, this is the solution goes from here. So let I is equals to. So this is what we need to prove, pi by 2 root 2 log root 2 plus 1. Okay. So we have integral 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. So this is equals to I is equals to 0 to pi by 2. In the place of x, according to this property, see what this property says, 0 to a same. In the place of x, upper limit minus x. So in the same way, in the place of x, wherever you find x, simply substitute upper limit minus x, pi by 2 minus x. So pi by 2 minus x by sine pi by 2 minus x plus cos pi by 2 minus x dx. This is equals to 0 to pi by 2 pi by 2 minus x by sin 90 minus x is cos x plus cos 90 minus x is sin x dx. Now 0 to pi by 2, this is pi by 2 by sin x plus cos x dx minus 0 to pi by 2 x by cos x plus sin x dx. This is I. This is all I. So this is equals to 2i is equals to pi by 2. I am separating from the process of integration. 0 to pi by 2, 1 by sin x plus cos x dx. So we know how to solve this problem in indefinite integration. So let us take let tan x by 2 is equals to t, dx is equals to 2 dt by 1 plus t square. I'm cutting the steps because this x by 2 is to be taken as x. Tan x derivative is secant square. X is x by 2 into dx is equals to dt. So 1 by 2, if you transpose that side, it will be 2. So 2 dt by, here tan square x by 2. If you, what is that? Secant square x by 2. Secant square x by 2 is 1 plus tan square x by 2, which is this. And sin x is equals to sin x in terms of tan, 2 tan x by 2 by 1 plus tan square x by 2. So 2t by 1 plus t square. And cos x is equals to 1 minus t square by 1 plus t square. And we need to change the limits as well. So upper limit is t is equals to tan x by 2. X is pi by 2 by 2. Tan pi by 4 is 1. Lower limit t is equals to tan 0 by 2 is 0. So totally in this way it has changed. So let us continue this. So 2i is equals to pi by 2 into 0 to pi by 2, it has become 0 to 1. 0 to 1. Okay. And dx is 2 dt by 1 plus t square. 2 dt by 1 plus t square by sin x is 2t by 1 plus t square plus cos x is 1 minus t square by 1 plus t square. So this is equals to pi by 2, 0. So this 2 gets cancelled. So pi into 0 to 1 dt by. So this is 2t plus 1 minus t square. So by 1 plus t square by 1 plus t square gets carried into integral 0 to 1 dt by. So this minus, if you take common, then t square minus 2t minus 1. So pi into, otherwise minus pi into 0 to 1 dt by. So this is the pure quadratic expression. Quadratic expression, whenever we came across, we need to do what? The completion of square method. So t square is t. I told you the shortcut as well. So we have to convert this in what is that? X square minus 2ax plus a square. So x minus a whole square. Instead of that, so t whole square minus 2 into, otherwise, okay, 2 into, instead of this, t minus, t quotient is 2, half of it. So 1, complete the square, minus 1 square is 1 minus 1 dt. So this is how I have told in my class. So this is minus pi 0 to 1 dt by t minus 1 whole square. Minus 1 is minus 2. So minus root 2 whole square we can write. Minus 2 can be written as root 2 whole square. So this is equals to pi 0 to 1 dt by. So if you multiply with minus inside, minus into minus is plus, root 2 whole square minus t minus 1 whole square. So this is equals to pi. This is the form 1 by a square minus x square. 1 by 2a. 2a is root 2 log a plus x by a minus x. Root 2 plus t minus 1 by root 2 minus of t minus 1. So minus t plus 1. So 0 to 1. So pi by 2 root 2 log, substitute the upper limit. So root 2, t is 1, minus 1 gets cancelled. So root 2 by root 2 minus 1 plus 1. So root 2. This is upper limit minus lower limit log root 2 t value is 0. So root 2 minus 1 by root 2 t value is 0 plus 1. So this is equals to, this is 1, log 1 value is 0. So pi by 2 root 2, this is log a by b can be written as root 2 plus 1 by root 2 minus 1 whole power minus 1. May I? This is log a by b can be written as log b by a inverse. So this is equals to, if this minus is already there, so pi by 2 root 2 into, so log a to the power of m log a. So this minus and this minus will be cancelled. So log, we get root 2 plus 1 by root 2 minus 1. So let us continue this. This is what I got. So I will rationalize the denominator. So root 2 plus 1 by root 2 plus 1. So pi by 2 root 2 log root 2 plus 1 into root 2 plus 1 is root 2 plus 1 whole square by a minus b into a plus b, a square minus b square. Root 2 square is 2 minus 1 square is 1. 2 minus 1 is 1. So pi by 2 root 2 into log a to the power of m log a. So 2 log root 2 plus 1. So 2 gets cancelled. This is 2i. Therefore, if I want I, this into 2 is to be transposed here. So pi by 2 root 2 log root 2 plus 1. This is of the form a to b f of x dx. We have integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. So let us take this to be I is equals to. So this I is equals to pi by, this is A and this is B. Okay. So pi by 6, pi by 3. What this property tells, wherever you find x, simply substitute A plus B. Sum of the limits minus the variable of integration. So square root of sine pi by 3 plus pi by 6 minus x by square root of sine pi by 3 plus pi by 6 minus x plus square root of cos pi by 3 plus pi by 6 minus x dx. So pi by 6 to pi by 3. Pi by 3 is 60. Pi by 6 is 30. 60 plus 30 is 90. So this is pi by 2 minus x. So this is pi by 2 minus x. Sin 90 minus x is cos x. So root cos x by. So this is 90 minus x. So root cos x plus this is cos 90 minus x is sin x dx. So given is a 1 and whatever we got right now is 2. So this is also I. 1 plus 2 gives rise to 2i is equals to pi by 6 to pi by 3 is same for both of 1 and 2. So the denominator is sin x plus cos x, root sin x plus root cos x. This is, if I add root sin x plus root cos x, this is root sin x plus root cos x dx. So one time integral 1 dx is x from pi by 6 to pi by 3. In the place of x substitute pi by 3. In the place of lower limit substitute pi by 6. Pi by 3 minus pi by 6. 2i is equals to. So this is equals to, I is equals to pi by 3 is 60. 60 minus 30 is 30. That is pi by 6. 2i is equals to pi by 6. Therefore, I is equals to pi by 12. So, integral minus a to a x square plus root of a square minus x square dx. So this is the form integral minus a to a. So we have a property that integral minus a to a f of x dx is equals to 2 integral 0 to a f of x dx if f of minus x is equals to plus f of x, or simply this value is 0 if f of minus x is equals to minus f of x. This we had discussed already. So let f of x is equals to, this function will take x square plus square root of a square minus x square. So f of minus x is simply minus x whole square plus square root of a square minus x whole square. So minus x whole square is x square plus square root of a square minus x whole square is x square. So minus x square. So what do we get is f of x. Therefore, f of minus x is f of x, which is even function. So even function means the given function integral minus a to a x square plus square root of a square minus x square dx can be taken as 2 integral according to this 0 to a x square plus square root of a square minus x square dx. Now let us split this 2 integral 0 to a x square dx plus integral 0 to a square root of a square minus x square dx. So 2 into integral x square dx is x cube by 3 from 0 to a plus this formula is well known to us. What is root of a square minus x square? X by 2 root of a square minus x square plus a square by 2 sine inverse x by a. So since the process of integration is over, so 0 to a is to be written here. So otherwise we will use this curly bracket. So 2 is getting multiplied with as a whole. So let us continue here. This is equals to 2 into, in the place of x substitute upper limit. So a cube by 3 minus, in the place of x substitute lower limit. 0 cube by 3 is simply 0 plus here substitute upper limit a by 2 square root of a square minus x is a square minus a square. So this will be 0 plus a square by 2 sine inverse x value is a by a 1 sine inverse 1. This is upper limit minus lower limit. So 0 you substitute here, 0 by 2 into something, so 0, a square by 2 sine inverse 0 by a is 0, so this is 0. So anyway we are left with this only. So this is equals to 2 into a cube by 3 or 2a cube by 3 plus 2 gets cancelled, a square sine inverse 1 is pi by 2. So integral 0 to pi x sin x by 1 plus sin x dx is given as usual. So let us take this to be I is equals to, and we have a favorite formula integral 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. This implies I is equals to 0 to pi, simply wherever you find x substitute upper limit minus x. So pi minus x sine pi minus x by 1 plus sine pi minus x dx. So 0 to pi. So pi minus x sine 180 minus x second quadrant positive. So sine x by 1 plus sine x dx. So this is equals to 0 to pi sine x by 1 plus sine x dx minus 0 to pi x sine x by 1 plus sine x dx. So this is I. So This is I. So this is all I only. So 2I is equals to 0 to, so this is equals to pi, 0 to pi. Here 1 plus sin x minus 1 by 1 plus sin x dx. I just added and subtracted 1. So pi into 0 to pi, 1 plus sin x by 1 plus sin x is 1. So 1 dx minus 0 to pi, 1 by 1 plus sin x dx. This is equals to 2y is equals to pi into integral 1 dx is x from 0 to pi minus 0 to pi 1 by 1 plus sin x. I'll multiply with 1 minus sin x by 1 minus sin x dx. So this is equals to pi, substitute upper limit pi minus substitute lower limit minus 0 to pi 1 minus sin x by a plus b into a minus b is a square minus b square. So 1 minus sin square x is cos square x dx. So pi into pi minus 0 is pi minus. So this is integral 0 to pi 1 by cos square x is secant square x dx minus 0 to pi sin by cos is tan x, 1 by cos is secant. So secant x tan x dx. So this is over. So pi into pi minus integral secant square x is tan x from 0 to pi minus integral secant x tan x is secant x from 0 to pi. This is over. So pi into, this is pi, tan pi is 0, tan 0 is 0. So this is 0 minus secant pi minus 1 minus secant 0 is 1. Secant pi is minus 1 minus lower limit minus secant 0 is 1. So this is equals to pi into pi minus 1 minus 1 minus 2 minus of minus pi plus 2. So this is 2i is equals to, therefore I is equals to pi by 2 into pi plus 2. We have done a little mistake. This is minus into minus, how much? Plus. So this will be plus, and this is minus 1 is minus 2 into plus, so pi minus 2. So this is the answer. The question is integral 0 to pi by 2 x sin x dx. We know how to do this problem. So this is product of, the integrand is product of two functions. X is algebraic function, sin x is trigonometric function. So let us take the help of the phrase I laid, where a comes first and t comes next. So this is f of x and this is g of x. So this is equals to first function into integral of second function sin x dx. So 0 to pi by 2 is to be written here, minus integral of 0 to pi by 2 d by dx of first function into integral of second function dx whole dx. This is equals to x integral sin x is minus cos x from 0 to pi by 2 minus 0 to pi by 2 d by dx of x is 1, integral sin x is minus cos x, integral sin x dx is minus cos x, dx is same. This is equals to minus, apply the limits. In the place of x, pi by 2 cos pi by 2 minus x is 0 cos 0 minus into minus plus integral cos x is sin x from 0 to pi by 2. So cos 90 is 0 into something 0, 0 into something 0, this is 0 totally. So this is sin 90 is 1 minus sin 0 is 0. So answer is 1. So the next problems onwards, we will use the reduction formula. We have integral 0 to pi by 2 sin power nx dx or 0 to pi by 2 cos power nx dx is n minus 1 by n. This is to be remembered, and from then on, so reduce the factors by 2. Reduce the successive factors by 2 both on numerator as well as denominator. And if n is even, we will be end up with the, so one situation will come, so 1 by 2, immediate the next term is to be written pi by 2. So, and the same goes like this, and if we get 2 by 3, the next immediate term will be 1, if n is odd. Integral 0 to pi by 2 sin power mx into cos power nx dx. So here, mainly two cases will arise. N is even, n is odd, that's it. N is even, n is odd. The first term is to be remembered, n minus 1 by m plus n. And the next time onwards, the successive terms will be reduced by both 2 on the numerator as well as denominator. And if we get 1 by m plus 2, the process is to be terminated, and the second stage, m minus 1 by m is to be remembered. And if you reduce it, the factors, the successive factors by 2, so 1 by 2 if we get into pi by 2, 2 by 3 if we get into 1. So if n is odd, n minus 1 by m plus n, until we get 2 by m plus 3, the next term is 1 by m plus 1. So we will do the problems based on this reduction formula. So let us quickly do this. Here m is even, or n is even, whatever it is, n is even. So the formula is n minus 1 by n, n minus 3 by n minus 2, etc. So if n is even, 1 by 2 into pi by 2 we have to end up, right? So now n is 4, 4 minus 1, 3 by, n is 4, 3 by 4, reduce the factors, the successive factors by both 2 on numerator and denominator term will be pi by 2. So the answer is 3 pi by 4 2s are 8, 8 2s are 16. So if you come here, n is odd here. So 7 minus 1, same. But here 2 by 3 into 1 is what we are getting, right? So 7 minus 1 is 6 by 7. So the further reduction is possible or not? Of course possible. So 4 by 5. Next further reduction 2 by 3. If 2 by 3 we get into 1 is the answer. So 3 2s are 6. 2 4s are 8. 8 2s are 16 by 7 5s are 35. And here n is even again. N minus 1. So 8 minus 1, 7 by 8 into further reduction 5 by 6. Further reduction 3 by 4 into 1 by 2. If 1 by 2 we get into pi by 2 is the final 1. So 3 2s are 6. So 7 5s are 35 pi by 7 5s are 35 pi by 8 2s are 16 16 4s 64 64 2s 128 2s 256. And if you come here, root a square minus x square. So this problem we have done like x by 2 root of a square minus a square plus x a square by 2 sin inverse x by a and on. But since this is the reduction formula, let us do this in the reduction formula itself. So let x equals to a sin theta. I told you a square minus x square, x equals to a sin theta is to be taken. Dx equals to a cos theta d theta. So we need to change the limits as well. Upper limit is a sin theta is equals to x is a gets cancelled, sin theta is equals to 1, theta equals to pi by 2. Next, lower limit a sin theta equals to 0. So sin theta equals to 0 degrees. So this is equals to 0 to a has been converted into 0 to pi by 2 square root of a square minus x square is a square sin square theta into dx value is a cos theta d theta. So this is 0 to pi by 2. Take a square in common, then a square into 1 minus sin square theta. So a square cos square theta. So a cos theta into a. So a square cos square theta d theta. So a square into, since m is odd, so m is even. So 2 minus 1, so 1 by 2. N minus 1 by n. 2 minus 1 by n. So 2 minus 1. So 1 by 2 into the next term is pi by 2. So pi a square by 4. So this is based on integral 0 to pi by 2 sin power mx into cos power nx dx. If n is odd, this is equals to n minus 1 by m plus n, n minus 3 by m plus n minus 2, etc. 2 by m plus 3 into 1 by m plus 1. So if n is even, comma m is given, so n minus 1 by m plus n, n minus 3 by m plus n minus 2, etc. 1 by m plus 2 into m minus 1 by m, m minus 3 by m minus 2, etc. 1 by 2 into pi by 2. So if n is even, m is odd, the same thing we are getting, n minus 1 by m plus n, n minus 3 by m plus n minus 2, etc. 1 by m plus 2 into m minus 1 by m, m minus 3 by m minus 2, etc. 2 by 3 into 1. So let us do this. So here n is odd. See, the power of cos is always treated to be n. So n is odd. N is equals to 5 odd. So use this. So n minus 1. So this is the formula to be used. What is n minus 1? 5 minus 1, 4 by m plus n. 4 plus 5, 9. Yes, further reduction is possible. 2 by 7. But here, further reduction is not possible. So we have to write m plus 1. So you may compare the previous term also. 2 by m plus 3 is 2 by m is 4. 4 plus 3 is 7. So we have started from this. Already ended with this. The next term will be 1 by m plus 1. 1 by m plus 1 is what? 4 plus 1, 5. So 4 2s are 8 by 4 2s are 8 by 9 7s are 63 5s 315. Now here n is even. N is even and m is odd. 5 is odd. So m is odd. So which one is to be used? This. N is even, m is odd case. So n minus 1. N minus 1 is 4 minus 1. 3 by 5 plus 4, 9. Further reduction is possible. 1 by 7. That means we have started from here and we ended with this. M plus 2. You may check it. M is 5. 5 plus 2 is 7. So the next part is to be started with m minus 1. So m is 5. 5 minus 1 is 4 by 5 into 2 by 3 into 1. So this is 3 gets cancelled. So 4 2s are 8 by 9 7s are 63 5s are 315. So the same answer like previous we got. Now here same. N is even. N is even. N is equals to 4 even. M is equals to 6 even. So this is the one to be used. What is N? N is 4. 4 minus 1, 3 by 6 plus 4, 10. Further reduction is possible or not? Always is to be checked out. So 1 by 8. Further reduction, if the numerator is reduced by 2, 1 minus 2 goes in a negative way. So therefore, we have to stop. And let us check. M plus 2 is 6 plus 2. So we have started with this. We ended with this. So the next part is M minus 1. M is 6. 6 minus 1. 5 by 6. Next 3 by 4 into 1 by 2 into the next one is 5 by 2. So 3 2s are 6. 5 2s are 10. So whatever we are left with will be the answer. 3 pi by 2 8s are 16, 16 2s are 32, 32 2s are 64 2s, 128 4s, 128 4s, 512. So this is not in a regular limits. The reduction formula for sin power mx into cos power nx dx limits is 0 to pi by 2 only, not 0 to 2 pi. Therefore, we have to apply a property. Let we have integral 0 to 2a f of x dx equals to 2 integral 0 to a f of x dx if f of 2a minus x equals to f of x and 0 if f of 2a minus x equals to minus f of x. So let f of x is equals to sin power 4x into cos power 6x. So f of 2 pi minus x, 360 minus x, sin power 4, 2 pi minus x, cos power 6, 2 pi minus x. So sin 360 minus x and sin 360 minus x is minus sin x, fourth quadrant, but whole power 4 even power makes it as sin power 4x into cos power 6x. So we get f of x only. Therefore, 0 to 2 pi sin power 4x into cos power 6x dx is equals to 2 integral 0 to pi, because what the property says 0 to 2a, 2 will come forward and upper limits half will it become. So 2 pi sin power 4x into cos power 6x dx. Again, this is not in 0 to pi by 2. So let f of x is equals to sin power 4x into cos power 6x. So f of pi minus x is equals to sin power 4 pi minus x into cos power 6 pi minus x. So sin 180 minus x is sin x whole power 4. So sin power 4x. But cos 180 minus x is minus cos x whole power 6. Even power makes minus positive only. So we get f of x only. So therefore, this can be 2 into 0 to pi becomes 2 integral 0 to pi by 2 sin power 4x into cos power 6x dx. Now we know how to do this. So 4 into n is even, m is even. So the case is this. So 2 into 6 minus 1, sorry, not this, 6 minus 1, 5 by 4 plus 6, 10 into further reduction is possible 3 by 8, further reduction is possible 1 by 6, and let us see whether we got to this or not. 1 by m plus 2, m is 4 plus 2, yes 6, into m minus 1, second part, m minus 1 is, m is 4 minus 1, 3 by 4 into 1 by 2 into pi by 2. So the simplification of this will gives the answer. So 4 gets cancelled. So 5 2s are 10. That's it. And 3 2s are 6. So whatever we are left with will be the final answer. 3 pi by 2 8s are 16, 16 2s are 32, 32 2s 64, 64 to 128. So this problem minus pi by 2 to pi by 2, again not in the regular limits 0 to pi by 2. So we have minus a to a f of x dx is equals to 2 integral 0 to a f of x dx if f of a minus x, if f of minus x equals to f of x, and 0 if f of minus x is minus f of x. So this is equals to, let f of x, I take it to be sine square x cos power 4 x. So f of minus x is sine square minus x cos power 4 minus x. Sine minus x is minus sine x whole square, so sine square x. Cos minus x is plus cos x whole power 4. Anyway, we get f of x only. So therefore, the given becomes 2 integral 0 to pi by 2 sine square into cos power 4 x dx. So this is equals to 2 into n is even, m is even, n is even, m is even case, n minus 1. So 4 minus 1, 3 by m plus n, 2 plus 4, 6. Further reduction is possible, 1 by 4. Further reduction is not possible. And let us take with the last one, m plus 2 is 2 plus 2, 4. The next part is to be started with m minus 1 by m. M is 2. 2 minus 1 is 1 by 2. If 1 by 2 we get, 5 by 2 will be the final answer. So 3 2s are 6. That's it. And this 2 gets cancelled. Pi by 4 2s are 8, 8 2s are 16. So we need to find integral 0 to pi x sine power 7x into cos power 6x dx. We have integral 0 to a f of x dx is equals to 0 to a f of a minus x dx. So this is equals to 0 to pi minus x sine power 7 pi minus x cos power 6 pi minus x dx. So 0 to pi minus x sine 180 minus x whole power 7. So sine power 7x, second quadrant positive sign is. Cos 180 minus x is minus cos, but even power makes minus positive. So cos power 6x dx. So 0 to pi into sine power 7x cos power 6x dx minus 0 to pi x sine power 7x into cos power 6x dx. Since it has come again, so previously let this be I to be taken. This is all I. So this is I. So if you bring here 2I is equals to pi integral 0 to pi sine power 7x into cos power 6x dx. Again, this is not in the regular format. Sine power mx into cos power nx dx is okay, but here 0 to pi by 2 is to be there. So let f of x is equals to sine power 7x into cos power 6x. Let us check f of pi minus x. So sine power 7 pi minus x cos power 6 pi minus x. Sine 180 minus x is sine x, but cos 180 minus x is minus cos, but even power makes. So sine power 7x into cos power 6x. This is f of x only. Therefore, this becomes 2I is equals to, according to property, integral 0 to a f of x dx equals to 2 integral 0 to a by 2 f of x dx if f of a minus x equals to f of x. So this is 0 to, this is pi into 2 integral 0 to pi by 2 sine power 7x into cos power 6x dx. So this is in the regular way. This is equals to 2 gets cancelled. So this I is equals to, so here 6 is even, n is even, m is odd. N is even, m is odd case. So n minus 1. So pi into n minus 1 is 6 minus 1, 5 by 7 plus 6, 13. Further reduction is possible. So 3 by 11. Further reduction is possible. 1 by 9. So let us check with this. 1 by m plus 2. So m is 7 plus 2 is 9. Okay. The next part is to be started with m minus 1. M is 7. 7 minus 1. 6 by 7 into, further reduction is possible. 4 by 5 into 2 by 3. The last term will be 1. So this is equals to, this is 5 gets cancelled. 3 gets cancelled. And 3 2s, 3 3s, 2 4s are 8, 8 2s are 16. 16 pi by 16 pi by. So this is 1311 into, if you multiply it, we will be getting 3003. So the next question, minus a to a integral x square into a square minus x square by 2x whole power 3 by 2 dx. Very first and foremost, let x is equals to, I'll take a sin theta. Dx is a cos theta d theta. Change the limits. A sin theta is equals to upper limit. Upper limit is a sin theta is equals to a. A gets cancelled. Sin theta is equals to 1. Theta is equals to pi by 2. Lower limit. A sin theta is equals to minus a. A gets cancelled. Sin theta is minus 1. Theta is equals to minus pi by 2. So the given integration will be minus a to a is minus pi by 2 to pi by 2. X square is a square sin square theta into a square minus x square is a square sin square theta whole power 3 by 2 into dx is a cos theta d theta. Everything we have here. So this is minus pi by 2 to pi by 2. A square sin square theta. If you take a square here, so a square into 1 minus sin square theta. A square cos square theta. So a square whole power 3 by 2 is a cube. Cos square theta whole power 3 by 2 is cos cube theta into a cos theta d theta. So this is equals to a square a cube a. This is a power 6 into minus pi by 2 to pi by 2. This is sin square theta into cos cube theta into cos theta is cos power 4 theta d theta. But this is not in a regular way. So we have to use the property. We have minus a to a f of x dx is equals to 2 integral 0 to a f of x dx. If f of minus x is equals to positive f of x even function. Let us check it out. Let f theta is equals to sin square theta into cos power 4 theta. F of minus theta is sin square minus theta cos power 4 minus theta. Sin minus theta is minus sin theta, but whole square is sin square theta. cos minus theta is plus cos theta. Even function whole power 4 cos power 4 theta. So this is equals to f of theta. Hence it becomes a power 6 into, this becomes 2 integral 0 to pi by 2. According to this property, minus a to a will become 2 integral 0 to a. So 2 integral 0 to pi by 2 sine square theta into cos power 4 theta d theta. So this is equals to 2a power 6 into, here n is even, m is even. So n minus 1, 4 minus 1, 3 by 3 plus 2 plus 4, 6, 1 by m plus 2, yes. And m minus 1, 2 minus 1, 1 by 2 into 5 by 2. So this is 2 gets cancelled. 3 2's cancel. So pi a power 6 by 2 4's are 8, 8 2's are 16. That's dx. X is equals to, let sine square theta I will take. Had it been 2 minus x, 2 sine square theta I would have taken. 3 minus x, 3 x equals to 3 sine square theta would have been taken. Okay. So dx equals to 2 sine theta into cos theta d theta. How? This is sine theta whole square. Sine theta is to be taken as x square derivative 2x. Sine theta derivative is cos theta, like that. So upper limit. Sine square theta is equals to, x value is 1. So theta is equals to pi by 2. So sine square theta is equals to, lower limit 0, theta equals to 0 degrees. So therefore, given will be in 0 to pi by 2, x power 3 by 2 sine square theta whole power 3 by 2 root of 1 minus x is sine square theta into dx is 2 sine theta cos theta d theta. So square root gets cancelled. This is equals to 0 to pi by 2 sine cube theta. 1 minus sine square theta is cos square theta, under root is cos theta. This will be, this is 2 sine theta cos theta d theta. 2 I am separating from the process of integration, 0 to pi by 2. This is sine cube theta into sine theta is sine power 4 theta into cos square theta d theta. So this is m even, n even case. So 2 into, so n minus 1. So 2 minus 1, 1 by 4 plus 2, 6. So the next part is m minus 1. 4 minus 1, 3 by 4. 1 by 2 into pi by 2. So this is equals to 3 2's are 6. 2 gets cancelled. So pi by 4 2's are 8, 8 2's are 16.